subscribe and press this bell icon to never miss another lecture video. Hi, welcome to Chair. We are in lecture number 68 of Signals and System, and still we are in the Fourier transform module. And here we are going to discuss a couple of very important questions which are associated with from duality concept and area under a graph, that concept. Okay, I think we have discussed about, I think I have not discussed about duality concept. I have only gave you the formula of duality concept and area under some curve or area under some graph, like the formula of that thing I have given you in the Fourier transform properties. Here we are going to briefly discuss the concept. It's a very simple concept, but it will give you extreme confusion. Okay, so please be careful with the concept right now. Listen to this carefully. Whatever things that I am saying, listen to this extremely carefully. Okay, we know the Fourier transform of e to the power minus at ut is nothing but 1 by a plus j omega. So this is a real exponential. We know the Fourier transform of a real exponential. We have the idea of real exponential, Fourier transform of real exponential. So what is the concept of duality? Now what if we know 1 by a plus j omega is nothing but the Fourier transform of e to the power minus at into ut. What if I'm going to ask you 1 by a plus jt? What is the Fourier transform of this? Sir, it get confused, sir, like, because if I'm going to do solve it like in this way, e to the power minus j omega t dt in minus infinity to infinity, the standard formula, the Fourier transform, if I want to take out the Fourier transform in this method, then this will get into a very difficult way, sir. So in order to get the answer for this kind of question, we actually developed a duality concept. Now we need to understand this concept, then only we can able to find out the answer to this question. We're going to discuss this question only in the first only. Okay, so let's start with the duality concept. Duality concept says, look here carefully, if there is x1t, listen to this carefully, very important. If there is x1t whose Fourier transform is x1 omega, if there is x2t whose Fourier transform is x2 omega, arrow mark means Fourier transform. Okay, if x1t whose Fourier transform is x1 omega and x2t whose Fourier transform is x2 omega, in question it will be asked what is the value of x2 omega. Please very careful about this concept. So x2t will be given, this will be given, and this will be asked. Okay, what is asked? x2 omega is being asked, sir. Absolutely correct. Now how to find out x2 omega, I'm sorry. So duality concept mein you need to take some assumption. In the first thing that you need to take, you need to find it out, like x2t, you need to take this assumption in this way. Listen to this carefully. x2t, the question that you have given, the given value that is given is very important, my dear friend. It creates a lot of confusion. Given is x2t. Okay, x2t is having resemblance or similarities, anything that you can say, of or with x1 omega. That means you need to write it down in terms of frequency component. That means you need to replace all the t part with omega. That will become your x1 omega. Then that means you got here, like you got this value. Now this became your given. Yes or no? Understand my English is going very shitty right now. Try to understand the concept. This is given, this is asked. Okay, always try to write down your question in this format. Now you need to find out x2 omega. To find out x2 omega, you need to find out x1 omega first. x1 omega is nothing but the similarities with x2t only. You'll understand from a question that we're going to discuss in the example. You'll understand that. But here you need to know the actual idea behind this concept. Okay, so x2t is nothing but similar to that of x1 omega. Clear? Now x1 omega we got. Now if you have a x2t which is showing a resemblance or similarities with x1 omega, that means your x1t, that means your x2 omega that we need to find out, x2 omega will nothing but x1t, it is 2 pi into x1t, where t is replaced by minus omega. This is your duality concept. That means you need to take it out like x1 omega, like you need to find it out the similarities between these two functions, and after that you need to find out x2t, x2 omega, which will be nothing but x1t into 2 pi, and replace t by minus omega. You'll understand from a question, the question that I have discussed with you, that is 1 by a plus jt. What will be the Fourier transform of this thing? Okay, I'll solve it for you. Please have a clarity in this thing. First thing, if you are doing it like first time, follow the method that I am going to show you. Please follow this method, it is very important. Once you are get expert with this method, you can do it in your mind, okay, in 1 minute or in 30 seconds. Okay, first of all, we know that 1 by a plus j omega, this is a usual, like we know, like हम इसको पहचानते हैं इस term को, right? We know this term. But if it is been asked in terms of time domain, it became a bit kind of complicated. So इसके लिए हम लोग क्या करेंगे, duality principle use करेंगे. So what you need to do, x1t, first write down x1t whose Fourier transform is x1 omega, and x2t whose Fourier transform is nothing but x2 omega. Now what is given? What is given? Given is, what is given? Given is, this thing is given, this thing is given, this thing is asked. Please have a clarity in this thing. This is nothing but your x2t. You have been asked to find out x2 omega. Please have a clarity this thing. So given is x2t, which is nothing but 1 by a plus jt. Now you need to take the assumption with x1 omega. You need to find out first, find out x1 omega. x1 omega will be nothing but the resemblance with x2t. Look, x1 omega is nothing but 1 by, just replace this t by omega, replace this t by omega. So x1 omega will be, so x1 omega, your this x1 omega will nothing but, we know it has to be x2t, it has to show resemblance with x1 omega. So hence x1 omega will nothing but 1 by a plus j omega. Clear this concept here? Now once you got x1 omega like this, you can easily find out what is the x1t subsequent. You can, from this x1 omega, you can find out what is the value of x1t, subsequent x1t value. x1t will be e to the power minus at ut. Clear? Now duality concept says the x2 omega will be, now if you find out, if you have already found x1t, then you can easily find out x2 omega, because x2 omega will be nothing but 2 pi into x1t, where t is replaced by minus omega. Clear this concept? So that means what will be my value? That means 2 pi into, what is x1t, e to the power minus at into u of t, where t is replaced by minus omega. That means the value will be now 2 pi into e to the power a omega u of minus omega. Clear this concept? This is your answer. This is your x2 omega. This is your x2 omega. This is the Fourier transform of 1 by a plus gt. Clear this concept? First stage, what you need to find out, you need to write down this format. Then after that, you need to have a clarity on these two things, that you got x2t that is similar to x1 omega, that must be similar to x1 omega, and from x1 omega you need to find out x1t. And once you found the x1t value, from x1t you can put the duality formula that x2 omega will be nothing but 2 pi into x1t at t equals to minus omega. We'll solve another very important question. It is very important question. It will give you a lot of clarity on a lot of things. Look here carefully. It is asked xt is equals to 1 by pi t. Okay, now in the similarly we're going to solve this. x1t Fourier transform is x1 omega, x2t whose Fourier transform is x2 omega. Now this value is nothing but given here, x2t is given here. You need to find out x2 omega, the Fourier transform of this value. So x1 omega will be, so x1 omega is nothing but 1 by pi omega. Okay, here there comes a very beautiful turning point. Listen to this carefully. 1 by pi omega. Okay, 1 by pi omega. Can you guess what could be its subsequent time domain value? Is there any expression which exists related to this? Sir, if my function is signum t, its Fourier transform will be somehow like 2 by j omega or something. Correct. So we need to format it in this way so that we can reach to signum t. So 1 by pi omega, this can be rewritten as j by 2 pi into 2 by j omega. Yes or no? I have just multiplied and divided by. Okay, I'm not going to bore you. You got this point. Now I just rewrote this format in order to reach signum t. Now this value is extra. So x1 omega, we got j by 2 pi into 2 by j omega. Okay, now you can easily, this is your frequency domain thing, you can easily, this is your x1 omega, so what will be x1t now? x1t will be j by 2 pi, j by 2 pi will going to lie like as it is, but 2 by j omega is nothing but signum of t. Clear this concept? So we got x1t value, very important here, very important. So from here x2 omega will be nothing but 2 pi x1t at t equals to minus omega. This is your duality. So 2 pi into x1t is this much, so j by 2 pi will going to lie as it is, and signum of, very important, minus omega, very important, very important here. So signum function, remember it is an anti-symmetric about y-axis, so it is an odd function. So signum of minus omega will be nothing but minus of signum omega. Yes or no? Odd function का formula क्या होता है? F of minus t is nothing but minus f of t. Yes or no? So signum of minus omega will be minus 2 pi j by 2 pi signum of omega. Correct. I think 2 pi will be cancelled out here. 2 pi will be cancelled out. So the answer will be minus j signum of omega. Now this is your x2 omega. This is your x2 omega. But answer in options in gate question, this will not going to given. So you got your like Fourier transform of 1 by pi t. You got the answer. That is nothing but minus j signum omega. Minus j signum omega. This is the value that you got, the Fourier transform of this thing, the answer. But this thing will be represented in this way. Very important representation. Please look here. X2 omega is nothing but minus j signum omega, which is nothing but, okay, let me write it down properly, which is nothing but minus j for omega greater than 0 and j for omega less than 0. Please have a very crystal clear clarity here. So this could be your value. Now it could be represented in this format. Minus j is nothing but minus j plus 2 mathematics. Minus j is nothing but Euler's formula, e to the power minus j pi by 2 or e to the power plus j pi by 2 for omega greater than 0, for omega less than 0. So very important observation is, please remember, all the information lies or present in phase spectrum. Okay, very interesting question. Very interesting. You can see in phase spectrum mein hi sare information hai. Very important question it is. We're going to discuss another important question, but before getting to that, there will be question which can be asked from duality concept but through area property. What is your area property says? Area property is nothing but, if in a time domain, if you take the integration like this value will be nothing but x of omega at omega equals to 0. That means x of 0. Clear? Similarly, x omega d omega agar integration loge in frequency domain, so answer will be 2 pi x of t at t equals to 0. That means 2 pi x of 0. Simple. Now let's solve couple of questions. Very important question. So sin t by t into dt ka whole integration, this can be solved by duality and area property. So how you are going to solve it? Like first you need to think of, like, this is your nothing but, this entire thing is your nothing but x of t. For example, this entire thing is x of t dt ka integration minus infinity to infinity, where x of t is nothing but sec t. This sin t by t is nothing but sec t. No, I can write it down in terms of sec t also. Yes or no? So instead of writing sin t by t, I can write down sec t. So x of t is nothing but sec t. So it is been asked ki xt dt minus infinity to infinity, what is the value? So value will be nothing but x of 0. This is the area property na, x of 0. So find out x of 0, I need to find out x of omega. So to find out x of omega, I need to find out the Fourier transform. That means x of t is given, I need to find out x of omega. That means I need to find out the Fourier transform of sec t. Once you find out the sec t, you can find out the x of 0 value. You just need to replace 0 in place of omega. Clear? Now let's do that. Sir, I have heard that if there is a rectangular function, rectangular function Fourier transform is a sinc function, sir. Now there is a sinc function whose Fourier transform will be obviously rectangular function. I told you in our previous video lecture. Now sir, I know the formula. I know the formula to write down from rectangular to sinc. That is area into sinc of width by 2 into w. Width by 2 by into w. This is the formula to find out from rectangular to sinc. But I have a sinc function. How can I write down the formula for rectangular function? I don't know, sir. Now you can use here duality property. Acha. Okay. Now how to use this duality property over here? Look here carefully. x1t, whose Fourier transform is x1 omega, x2t whose Fourier transform is x2 omega. Clear? Now here x1t is nothing but sinc t. You need to find out x2t. You need to find out x2t. It is given. You need to find out this one. So x1 omega is nothing but sinc omega. Yes, if you have a sinc omega as your x1 omega, what will be the subsequent x1t would be? What will be the subsequent x1t will be? X1t will be the so you can find out here, like this is represented in terms of this is your area value and there must be some width by 2. So you can see here area is 1 here and width by 2 is given as 1 here. So from here you can guess area is 1. So this rectangular pulse in such a way that area is 1. Let's take the magnitude 1. That means that this must be minus 1 by 2 to 1 by 2, and width by 2 is 1. Okay, width by 2 means this part it has to be 1. Okay, let's take 1 and minus 1, then this must be 1 by 2. So this must be your rectangular function. Clear this concept? How we got from sinc function to a rectangular function? How we got? Because sinc function says area into sinc of width by 2 into w. So width by 2 is 1, area is 1. So I can guess the rectangular function could be minus 1 to 1, whose width by 2 is 1 and whose area is 1. Clear this concept? So x1t is nothing but a gate function or rectangular function. You can anything you can say, a rectangular function or gate function, which is given as like this. That is minus 1 to 1 and this is 1 by 2. Clear this concept? It's a very simple concept. So once you got the rectangular value, how to write it down, this rectangular function, in terms of like equation. Look here carefully. Magnitude, you need to write down the magnitude first into rectangular function can be written like this. Clear? This is your x1t. So if this is your x1t, so what will be x2 omega? X2 omega will be x1 2 pi into x1t of t at equals to minus omega. Yes or no? So that implies 2 pi 1 by 2 g of t minus omega, like this. And we know g of t minus omega is nothing but an even function, so g of minus omega is nothing but 2 pi into 1 by 2 g of t omega. Yes or no? 2 will be cancelled out, so the answer will be pi into g of t omega. This is your Fourier transform of x2t. But we need to find out the area. That means we need to, this is x2 omega, that this is the value that we got, x2 omega. We got pi into g of t omega. But here in question we need to find it out, the integration of that thing. We got the Fourier transform of sinc t is that. We got a Fourier transform of sinc t is this much. Now we need to find out the integration of this thing. That means that will be f of 0. That will be nothing but f of 0 or x of 0 in frequency domain. So this value will be pi into g of t of g. Now let's moving on to the next kind of question, that is sinc square t into dt ka integration. So it's as simple as that of the previous question. So here it is been asked, so you need to write it down, x1t whose Fourier transform is x1 omega, yes, x2t whose Fourier transform is x2 omega, and x2t is given, that is sinc square t. Yes or no? Sinc square t. And you need to been asked that to find out x2 omega, find the value of x2 omega. To find it out, you need to write down x1 omega will nothing but sinc. So this question can be modified and can be rewritten like this. That means sinc square t dt integration minus infinity to infinity. So this value will be f of 0. So f of 0 will be the value. What is f of 0? F of 0 will be nothing but, you need to, I'm sorry, the Fourier transform of this thing. If sinc square t, Fourier transform of this thing is x of omega, right, then sinc square t dt will be nothing but x of 0. Integration will be nothing but x of 0. This is what your area property is. Now x1 omega, you can take it like your sinc square, you can take it like your sinc square omega. Yes or no? If your x1 omega is sinc square omega, from here you can take the like assumption what will be your x1 t would be, what will be your x1 t would be, what will be your x1 t will be. So to find it out, you need to represent it in this form. You can see your area is 1 and width by 4 is 1. That means your function must be looks like this, minus 2 to 2, that is 1 by 2. Yes or no? So your x1 t is nothing but 1 by 2. So x1 t is nothing but 1 by 2 triangular t by 2. You know the triangular equation, right? Now if you got this value, so you can write down x2 omega will be nothing but 2 pi into 1 by, so you can write down 2 pi into 1 by 2 into triangular into omega by 2. Okay, you can replace t in place of minus omega, and we can replace minus omega by plus omega because it is an even function. Simple, pi into triangular omega by 2. Clear? Now here you can clearly see x2 omega value is this, but we need to find out x2 of 0. This is the value that we need, no, x of 0. So x of 0 will be pi into triangular of 0. This will be your answer, pi into triangular of 0. Clear? This is your answer. Okay, understand this concept. This is a very important concept and very important analysis, duality and area property. The question will be very easy, and the thing you need to be like understand the trickiness of the question. From the next video and onwards, we'll get into the bandwidth concept and the ideas which are associated with bandwidth, Parseval's theorems, and power spectral density. All of those concepts will going to get started from the next video lecture. Okay, keep watching GATE. Thank you. Bye.